Your organization needs a hybrid cloud solution to securely connect on-premises data centers with AWS. The connection should have consistent performance and low latency. Options: A. Use a site-to-site VPN connection. B. Use AWS Direct Connect. C. Use an Internet gateway and public IPs for EC2 instances. D. Use VPC peering to connect the on-premises data center with AWS. Correct answer: B. Use AWS Direct Connect. Explanation: AWS Direct Connect provides a dedicated, low-latency, high-performance connection for hybrid cloud architectures. Why not other options? Option A. VPN connections can have inconsistent performance due to internet dependency. Option C. Internet gateways expose resources to the public internet, which is insecure. Option D. VPC peering is for connecting VPCs, not on-premises environments. You are designing a highly scalable web application that should automatically scale based on traffic demands. The application needs to support thousands of concurrent users without downtime or performance degradation. Options: A. Use EC2 instances in an auto-scaling group with elastic load balancing and Amazon RDS for data storage. B. Use Lambda functions with API Gateway for stateless processing and DynamoDB for storage. C. Use EC2 instances with elastic load balancing and Amazon S3 for static content storage. D. Use Amazon ECS with Fargate for containerized applications and Amazon Aurora for data storage. Correct answer: A. Use EC2 instances in an auto-scaling group with elastic load balancing and Amazon RDS for data storage. Explanation: Option A provides a scalable solution with EC2 instances, auto-scaling, and elastic load balancing for handling high traffic. Amazon RDS offers relational storage for dynamic data. Why not other options? Option B. Lambda and API Gateway are suitable for stateless applications, but they may not provide sufficient flexibility and performance for a large-scale web application with complex back-end interactions and session management. Option C. Using S3 for static content is appropriate for serving static assets, but it doesn't provide the dynamic scalability and back-end processing needed for the full application. Option D. ECS with Fargate is good for containerized applications, but the use of Aurora might not be necessary if simpler relational databases like RDS are sufficient, and it introduces more complexity for this scenario. Your company wants to implement a disaster recovery strategy for an application that must be available across multiple regions. The application should fail over to another region if the primary region goes down. Options: A. Use AWS Global Accelerator to route traffic to the nearest region. B. Use Amazon Route 53 with health checks to route traffic between regions. C. Use AWS Direct Connect to replicate the application in multiple regions. D. Use Amazon S3 to replicate static content between regions. Correct answer: B. Use Amazon Route 53 with health checks to route traffic between regions. Explanation: Option B enables DNS-based failover routing between regions with health checks to ensure the traffic is directed to the healthy region. Why not other options? Option A. AWS Global Accelerator is optimized for improving global application performance and routing traffic to the closest endpoint, but it doesn't directly address failover between regions for disaster recovery. Option C. Direct Connect is a dedicated network connection to AWS, but it's more for private connectivity rather than managing traffic failover between regions. Option D. S3 replication between regions is useful for static data, but it doesn't provide a solution for routing application traffic or managing failover. You are designing a system that ingests telemetry data from IoT devices. The data needs to be processed in real time, analyzed, and stored for further querying. Options: A. Use AWS IoT Core with DynamoDB for device data storage. B. Use AWS Lambda with SQS and S3 for storage. C. Use EC2 instances with autoscaling and RDS for storage. D. Use Amazon Kinesis data streams with Lambda for processing and DynamoDB for storage. Correct answer: D. Use Amazon Kinesis data streams with Lambda for processing and DynamoDB for storage. Explanation: Option D is designed for real-time streaming data processing. Kinesis provides the mechanism to ingest data, Lambda processes the data, and DynamoDB stores the data. Why not other options? Option A: While AWS IoT Core and DynamoDB work for IoT device connectivity and storage, it's less focused on real-time data processing compared to Kinesis. Option B: Lambda and SQS are good for decoupling systems but aren't optimized for continuous real-time data ingestion and analysis as Kinesis is. Option C: EC2 instances with auto-scaling and RDS would require more management overhead, and using RDS for IoT data is generally less suitable for the scalability needs of real-time telemetry data. You need to ensure that your web application is highly available, with minimal downtime, in a single region. The application must have fault tolerance and be able to recover from hardware failures. Options: A: Deploy the application on EC2 instances in an auto-scaling group across multiple availability zones with an elastic load balancer. B: Deploy the application on a single EC2 instance with an elastic load balancer. C: Deploy the application on Amazon Lambda functions with API gateway. D: Deploy the application on EC2 instances with Amazon Route 53 routing. Correct answer: A: Deploy the application on EC2 instances in an auto-scaling group across multiple availability zones with an elastic load balancer. Explanation: Option A provides high availability by distributing EC2 instances across multiple availability zones and using auto-scaling to handle demand. Elastic load balancing ensures traffic is distributed across instances. Why not other options? Option B: A single EC2 instance introduces a single point of failure, and using only an elastic load balancer without multiple instances across availability zones does not ensure high availability. Option C: Lambda functions with API gateway are ideal for stateless workloads, but might not provide the same level of performance and control as EC2 for complex web applications. Option D: Route 53 routing is more useful for global DNS management rather than handling traffic balancing and failover for application-level redundancy. You need to store sensitive data, such as credit card information, and it needs to be encrypted both at rest and in transit. Which service should you use? Options: A: Use Amazon S3 with server-side encryption and HTTPS for secure transfer. B: Use Amazon RDS with encrypted storage and SSL for encrypted connections. C: Use AWS Lambda to process data and store it in DynamoDB. D: Use Amazon EFS with encryption at rest and in transit. Correct answer: B: Use Amazon RDS with encrypted storage and SSL for encrypted connections. Explanation: Option B ensures that data is encrypted at rest, with RDS encryption, and in transit, using SSL connections. Why not other options? Option A: S3 provides encrypted storage and HTTPS transfer, but it is better suited for object storage, not for managing transactional data like credit card information. Option C: While Lambda and DynamoDB can be part of a solution, they do not directly address the specific needs of encrypting sensitive transactional data at rest and in transit like RDS does. Option D: Amazon EFS offers encryption at rest and in transit, but it's typically used for shared file storage and not a relational database solution, which would be required for managing sensitive data such as credit card information. You are tasked with implementing a backup solution that stores large amounts of data at a low cost while ensuring it is easily retrievable when needed. Options: A: Use Amazon S3 with standard storage class. B: Use Amazon S3 Glacier for long-term archival storage. C: Use Amazon EBS volumes for data storage and EC2 for processing. D: Use Amazon Elastic File System, EFS, for data storage. Correct answer: B: Use Amazon S3 Glacier for long-term archival storage. Explanation: Option B offers the most cost-effective storage for long-term backup and archival data. S3 Glacier is designed for infrequent access and long-term storage at a low cost. Why not other options? Option A: S3 Standard is great for frequently accessed data but is not cost-effective for long-term backup storage where retrieval times are not urgent. Option C, EBS volumes and EC2 would be more expensive and less efficient for long-term backup storage. EBS is typically used for storing data attached to EC2 instances. Option D, Amazon EFS is designed for scalable, shared file storage, but it is more expensive than S3 Glacier for archival and backup purposes. You need to host a static website that receives high traffic volume. The website content includes images, videos, and other static files. Options: A. Use Amazon S3 with CloudFront for content delivery. B. Use EC2 instances with an auto-scaling group and S3 for static content. C. Use Lambda functions to serve static content from S3. D. Use AWS Elastic Beanstalk for hosting the static website. Correct answer: A. Use Amazon S3 with CloudFront for content delivery. Explanation: Option A is the most cost-effective and scalable solution for hosting static content. S3 provides scalable storage, and CloudFront ensures fast content delivery worldwide through its Content Delivery Network, CDN. Why not other options? Option B, using EC2 instances with auto-scaling introduces unnecessary complexity and cost, as S3 and CloudFront can serve static content efficiently. Option C, Lambda functions are not needed for serving static content from S3. CloudFront is a better solution for caching and distributing static content. Option D, Elastic Beanstalk is typically used for deploying dynamic web applications, not for hosting static websites. S3 and CloudFront are more appropriate for static content. You need to decouple the components of a microservices-based web application to allow each service to scale independently and avoid direct dependencies. Options: A. Use Amazon SQS to queue requests between services. B. Use AWS Lambda for all microservices. C. Use Amazon SNS to publish and subscribe between services. D. Use AWS step functions to coordinate microservices. Correct answer: A. Use Amazon SQS to queue requests between services. Explanation: Option A is ideal for decoupling services. SQS allows asynchronous communication, enabling services to operate independently and scale on demand. Why not other options? Option B, while AWS Lambda is great for serverless architecture, it's not always suitable for complex microservice architectures where you need message queuing and asynchronous processing. Option C, SNS is more suitable for pub/sub messaging patterns, but SQS is better for decoupling services that need to process requests asynchronously in a queue. Option D, AWS Step Functions is used for orchestrating workflows and service coordination, but it might be overkill when simple queuing and decoupling are needed. You are using Amazon RDS for a relational database but are experiencing high read latency during peak hours. You need to optimize the database's read performance. Options: A. Use Amazon RDS Read Replicas to distribute read traffic. B. Use Amazon Aurora with read scaling enabled. C. Use Amazon ElastiCache for caching frequent queries. D. Increase the instance size of the RDS database. Correct answer: A. Use Amazon RDS Read Replicas to distribute read traffic. Explanation: Option A allows for distributing read queries across multiple replicas, reducing the load on the primary database and improving read performance. Why not other options? Option B, Aurora's read scaling is useful, but is typically overkill when RDS read replicas can already handle the need for read scalability. Option C, ElastiCache is a good option for reducing database load by caching frequently accessed data, but read replicas are better for optimizing read-heavy database traffic. Option D, increasing the instance size may help, but it does not address the underlying issue of distributing read traffic. Read replicas offer a more scalable solution.